So hello everyone, welcome back to the channel. Today we are going to solve the problem second smallest number. So the task is to find the second smallest number with a given sum of digits as s and a number of digits as d. So basically we have to find the second smallest number through which when we add the digits we will get the sum s and we have to take the number of digits as d. So let's discuss with an example. So let us given we have given something like this s is equals to 16 and d is equals to 3. That means we have to assign this number in 3 digits. So here we have to give the numbers such that after they will sum, if they will, when I will add them, then it will give 16. So how can we do that? So we can add 1 plus 6 plus 9, which will give 16, or we can add 1 plus 7 plus 8, it can also give 16, or we can add 1 plus 8 plus 7, it can also give 16. So we have many possibilities like 2 plus 5 plus 8, it can also give 16. We can have many possibilities. No, it can be 6 also. It should be 6. So yes, so it can also give, so many possibilities are available, but we have to find the second smallest number out of them. We have to find the second smallest number out of them. So how can we do this question? So let's understand some observation, like what are the observation that we can get so as to approach the answer. So let's discuss. Let us say we are given some number. Forget the question for now. Let us consider like we are given these numbers. Now, how can we generate the smallest number out of them? We can generate the smallest number when we will take the smallest number add, next smallest number add, next greatest number at last. That is the smallest number. Means 1, 1, 1, 2, 2, 8, 8. This is the smallest number. What if I take 8, 8 ahead? That will give the greatest number. 1, 1, 2, 2 is smaller than 1, 1, 8, 8, 2, 2. So that means as smaller number I keep ahead, as such more smaller number will be available. That means in the other way I can say that I have to keep at front as smallest number as possible. I have to keep at front as smallest number as possible. Okay, so this is the first observation, that I have to keep as smallest number at front as possible. Also, we can also say we have to keep as greatest number beyond behind as possible. We have to keep greatest number ahead, we have to keep smallest number ahead. That means we have to keep it in sorted position. We can also say, okay, this is the first observation. What is the second observation? Let us say we are given two tests here, 389 and 299. Which one is like I have added commas, 389, 299. Which one is smaller? This one, 299 is smaller. Why? Because let us compare them. Because this 2 is smaller than 3. That means always the first number is the deciding factor for a number, is smaller or not. Let's say because 200 will come before 300, na? Because 200 will come before 300. So we can say 299 will be smaller obviously before, since it comes before 389. This is the intuition or observation behind this. Why should we keep smallest number ahead? Also, second observation that we made, we have to keep greatest number behind. So how much greatest number should I keep it? I should add, like, I can add 8, I can add 9, I can add 7, I can 6, as many as possible. But let us see these two test cases again. Like here is 299, this is 389. So here we can see like 9, okay, 9 and 8. So because we are given sum is equals to s, because we are given sum is equals to s, we have to complete the sum. Since we have to complete the sum, so we will add 2. So then it will increment this number. But when we are taking 3, it will decrement this number obviously. Why? Because we have taken greater number ahead. If I take greater number ahead, we will reduce the previous number. We will reduce the previous number. So main observation behind this question, we can see that we have to keep as many 9s at last as possible. Why? Because as greater number at back, as smaller number will be there. Because we are reducing the sum by 9, 9, 9, 9. So as many 9s I will decrease, sum will become more smaller. More smaller the sum, so I will add small number here. This is the observation that I have to keep as greater number, that is as 9s as possible at the end. So final conclusion after the two observation is we have to keep as many 9s at end as possible. This is the final conclusion. So let us consider a test case like sum is equals to 35. So how can we represent it? Our observation that we have to keep as many 9s as possible at the end. So we will keep 9. 35 minus 9. Let's say we are given 4 digit. We have to accommodate it in 4 digit. So 35 minus 9 will be 26. Yeah. Yes. So next 26 minus 9, we will keep this 9 here. 26 minus 9 will be, this will be 17. So now 17 minus 9, we will keep 9 here. We have kept 9 here. We have kept 9 here. We have kept 9 here. 17 minus 9 is 8. Now add then 8 is left, so we will keep 8 at the front. Okay, so that is the sum that I can approach. So we have to keep as many 9s as possible, and at the end, whatever number is left is the we kept as it is. Okay, now here comes a like test case which will fail here. Like here 0, 0, 0, 8, 9, 9. What if this will be? Let's say sum is 35 again, but we are given number of digits as 7, 8. As you can, let's for test case we can consider the number of digits are 7. We will keep 9. We will keep 9. We will keep 9, and whatever number is left we will keep 8, 0, 0, 0, 10. Now, but they are 4 digit because add is 0, but we want 7 digit. For 7 digit, what we can do? We can do that we will reduce this numbers to 7, and we will increment this number. We were decrementing minus 1, we are incrementing plus 1, so as to make the sum as it is 35. So we will decrement this number, we will increment this number. This will become 1007999. Now, why should I increment by 1? Why should I decrement by 1? I can increment by 2, I can increment by 3. No, this is not, because we want smallest number. So for smallest number, as I said, 1001, 2001. Which one is smaller? This one. Why? Because first smaller number will be the deciding factor. Let's say add 2, 2. So these are same. Okay, fine. So first smaller number is 1. So 1 is the smallest number. So we have to keep as smallest number at front. Okay. Now why we are decrementing from 1 from here? Why not from here? Because let's say here given 0, 0, 0, 8, 9, 9. We are given 0, 0, 0, 8, 9. So I will decrement to 7, and I will make this one. So this will become 10079. Okay. Let us consider like if I decrement it from here, this will become 8. This will become 1. What will be 1000898? Again, the same thing. What I said, that I have to keep this 1, 1 matching, 0, 0 matching, 0, 0 matching, 7 and 8. 7 is smaller. Why? Because we are removing the first means front number as smaller, because I can't decrement zeros. So I should decrement the number which we can decrement and can add it here. So that's why we have taken front number, first front number to decrement minus 1 and added the 1 at front. So finally, what we want for the first smallest number, for conclusion, we can say we have to keep as many 9s as possible. What if 0, 0 comes? If at front any point 0 comes, we will make this 1 and we will decrement this to minus 1. So this is the first smallest number. So this is really easy. Okay. Now, what is second smallest number? How can we get the second smallest number? Now, for second smallest number, we can see, let's do some observation. Let's say we are 1 to 5. 1 to 5. Now, what will be the next greater number? Second smallest number means next greater number of the smallest number. So 1 to 5. What is the next greater number? This is the sum 8. We want sum again 8. What is the next greater number? So if I observe 1, 3, 4. Okay. Now again find sum is equals to 8. 1, 4, 3. But we can observe. We can observe that this number is incrementing and this number is decrementing. This number is incrementing, this number is decrementing. That means for finding the second smallest number, we have to decrement the number. We have to decrement the one number. One number should be incremented and one number should be decremented. Okay. But which one should I decrement? Which one should I increment? So let us consider test case like 1000893. This is the first smallest number. Okay. Now, this is the first smallest number. Now I can see here like this is here 9 is given. So can I increment it? No, this will become 10 and 10 is not one digit number. Okay. Now let us discuss this. Can I? No, again. Can I increment this? Yes. Yes. So I will increment this. It will become 9. And I will decrement this. This will become 8. Okay. So what we will do, we will traverse until we do not get 9. And whenever I do not get 9, I will increment that number by 1 and decrement the next number by minus 1, because next number is already 9. So we have to decrement that number. So this is a test case. Now let's see here come test case like 9 is not available. So when 9 is not available, we will come to second last position and increment this one and decrement this by minus 1, that will become 7. Now, so why it is working, like as I already said, whenever a last second number is incremented and last number is decremented. So we have to understand for getting the second smallest number, we have to decrement last number. We have to decrement the last number and we have to increment the last second number. But why we are traversing 9? We are traversing 9 because we can't increment or decrement. We can't increment it basically. Decrement, we can decrement. We can't increment it. Why? Because 9 will become 10 and this is not a single digit number. So we will say that we can decrement it. So we have to skip those cases which are 9 until I get a number which can be decremented. So which can be incremented because 8 can be incremented, 9 cannot be incremented. So that is the thing. So for finding second smallest number, so first smallest number, what was first smallest number? I have to traverse and add the 9, as many 9s as possible. For second smallest number, what I have to do? For second smallest number, I have to traverse until I get 9s. And when I do not get 9, that number will be incremental 11 and this next number will be decremental 11. Let's say here 100,899. What if I increment it? This will become 100,989. So this is the next smallest number. When you observe, you will get that this is next smallest number. As I already said, that for this is observation. This is somewhat observation that have no reason that number will be incremented and next last number will be decremented and last second number will be incremented. This is observation. So let's do the code and understand it side by side. So how can we do that now? Let us say now we have some exception cases. Let's say sum is equals to 1. So when sum is equals to 1, let's say for this test case, sum is equals to 1. Sum is equals to 1. So that means single number will be there. Now when sum is equals to 1, I can represent in as many digits like this. 1, 0, 0, 0. Okay. Or in one digit, I can represent it like this. Two digit, three digit, I can represent it like this. Two digit. Okay. Now if I say I want the second smallest number having the sum 1, is it possible? No. Why? Because if I will, let's say increment it. Let's say I will increment it last second number and decremented. This is minus 1. Minus 1 is not a valid digit. So we will say that if sum is equals to 1, it is an invalid case because sum is equals to 1 can be represented only in one form. That is this one. 1, 0, 0, 0. This. We can't represent sum is equals to 1 in any other form. So this is an invalid test case. Now second case, when d is equals to 1. Why? When d is equals to 1, when digit is equals to 1. When number of digits is equals to 1, here is 9. Let's say digit 7. So these are one digit, one digit, one digit. So can we represent it in any other form? In a single digit form, I can't represent any number in any other form. So for a single digit, it will also be. Okay. Now here come a different case like at max, how much sum I can get from a given string. Let's say I have 4-digit number. At max, I can add 9 here. 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 So I can't get sum greater than this 9. 9 into 9, 9 plus 9 plus 9 plus 9. That is 9 into 4. So I can't get sum greater than 9 into 4. Greater than 9 into 4. I can't get this sum. So whenever sum is greater than 9 into 4, whenever sum is greater than 9 into 4, 9 into basically not 4 digit. This will be written minus 1. Now, here other exception that what if number is 999. Let's say our sum was 36 and we have to add it in 4 digit. 9999. Then now can I represent in any other form? All were nines. I can't increment them. This will not be a single digit if I increment them. So no one can be incremented. So its second form is not possible. Second smallest number, how we are finding? By incrementing or decrementing. I can't increment. I can decrement, but I can't increment. So that means this is also an invalid case. So when sum is, I am adding separately, but I can also add condition here, but I am adding separately for understanding properly. Like if sum is equal to 9 into d, that means sum is equals to that number of digit 9999. I can't increment it or decrement it, so that means we will return minus 1. So these are exceptions. Okay. Now let us consider string answer d comma, or we can represent. Hmm. So let us represent the string answer d comma. Let's say I can add any character, zero, dollar, anything. Let us consider string. Okay. Now if we will add sum is equals to s initially. Now let us consider a last variable. We will understand why we are taking. Okay. Now what we will do? We will traverse from the back and we will check if sum is greater than 9. That means I can add 9 here. I want to add as many 9 as possible. So this is the process of finding what we are doing first smallest number. If sum is greater than 9, we will make answer I is equals to 9. Okay, now, and we are starting from the backward, 9 9 9 9. So sum is equal to sum minus is equals to 9. Okay, because we have to decrement this. Now if sum is greater than 0, what that means? That means that answer I is equal to 0 plus sum. Okay, also what we will do, sum is equals to 0, because if the last number, let's say 8, so just 8 will be there and sum will become 0, because I can't no more add. Add will be 0 0 0. Like if I take this, if I am adding 9 9 and added 8, so I will add 0 0 0, sum will become 0 now. So that's why I'm taking this condition. Now here come a case. Now second case, when the sum will be equal to 0, then I will just add directly 0 at every point. I'm just then okay. Now this was the process of finding this. Now here we come back to the board. Like here 1 0 0 0, this is the case. This is a different case. Now here 8 is there, as I told, when a number comes, and here is 0, this is invalid case. Why? Because I am not making 6-digit number. We have to make it 6-digit number. So what we will do, we will decrement this by 1, we will increment this by 1 to make the number as small as possible. So what we will do, if the first position contains 0, if the first position contains 0, then that means this is an invalid case. We have to make this valid. We have to make this valid by last number, whichever last number is available, 1 2 3 4 5 6, anything is available. We will decrement this by 1 and increment this first point by 1. So what we will do, that if answer of 0 is equal to 0. Now, how we decrement this last number? That's why I'm maintaining the last one. That whenever the last number is left, we will mark this as I. So this will be the last. This will be the last. So the pointer will be here. Last number will be here. This is the 0th position. So we will array of 0 plus 1, and array of last will be minus is equals to 1. So what we will do? We will answer 0 will be equals to 1. We can add directly 1 also. And answer of last minus is equals to 1. So now this. Now this was the first smallest number is found. Now we are finding the second smallest. How we can find it? As I told, what we will do, we will move until I get 9s. Now here comes something different. Like let's say I am here 1003. Now I will start from here. I have not found one. I will increment this by 1. I will decrement this. There is no index. There is no index here. So at most I have to, at least I have to be at position n minus 2. And this is n. This is n minus 1. This is n minus 2. So at most I have to be at position n minus 2 to increment, and next number to decrement. So let's say at least I have to add second last position. So while answer of L is equal to 9, we will decrement this, and at the end we will increment that number by 1. Like here, since I do not get 1, so I will be do not get 9, so I will remain here only. So it will become plus 1. It will decrement, so it will become 1012. And you can also check when while dry running that it will come 1012. As I told, as I explained the intuition behind that. This is observation list. So and then answer of L plus 1 will be decremented by minus 1. So just like that. Now after that, what do you have to do? You have to return the answer. This was just the question. So in the first, we are finding these are exceptions. These are first smallest number we are finding, which was very easy. Put as many 9 as possible. And if first number is 0, that means it is an invalid case. So for invalid case, what we will do? We will add 1 ahead and take the number from the any number which is available, like any number which is available ahead. Like it was 9, let's say 8, and this was 0. So I will make this 7, make this 1. So this was a number which is which has something available. Okay, so this was the case. Now second smallest number, we will move back until we get 9, and after that we will add plus 1 and minus 1 to get the next second smallest number. If the question was, let's compile it, the code. So here is sum is equals to 9. So basically it is S and it is S. Let's check again. Let's submit the code. Yep, and it is running fine. So the question was all about observation. I also made this observation that I have to keep as many 9s as possible, and so that as many 9s will be at back, more smaller number will be ahead, and more smaller number will be ahead, more smaller will be the our final number, and next number can be just found by answer of L plus 1 and answer of L plus 1 minus 1. Because I cannot increment 9, so we have to move until all 9s are skipped. We have to skip all lines from the back. Now this is all about the code. So thank you. Have a nice day.